Okay, this is section 3.3. We're going to discover the exponent laws. So again, we're going to be dealing with powers. Remembering, of course, the difference between the base of a power and the exponent of a power and that particular nomenclature. So 3.3, we're discovering the exponent laws. Again, we're not going to do the investigate. It gets into units, and then we don't use it at all in the homework. So we're going to skip through that and just go straight to... actually, I want to look at these. There's a couple tables in the exponent, in the investigate, that are worth doing. So the first one is 3 to the exponent of 2 times 3 to the exponent of 4. So we know 3 squared is 3 times 3. And we know 3 to the exponent of 4 is 3 times 3 times 3 times 3. So we end up with this long expanded form. Now if we take that expanded form and convert it into a single power, I hope you can all appreciate that that's going to be 3 to the exponent of 6. Right? 1, 2, 3, 4, 5, 6. So 3 times itself 6 times. So what do we notice about this single power and these two powers here? What do we notice? Yeah.
You added the exponents.
Yeah, so we just added the exponents and we got 6. So let's try that one more time. So we'll do 4 times 4 times 4 times 4 times 4 times 4. So if we count those, 1, 2, 3, 4, 5, 6, this is 4 to the exponent of 6. All right? So we notice the same pattern is happening. Okay, whenever we have two powers multiplied with the same base, very important that the base is the same. The base, of course, being that number 3 and that number 4, we can just add the exponents. Okay, that's how we multiply powers. So we'll check it out again. 6 times 6 times 6 times 6 times 6. We get 6 to the exponent of 5. Any questions about that? Yeah, Tyler.
Does this only work for multiplication?
No, it's going to work for other stuff. We're not there yet. Okay? So if we go down to this last example, k3 times k5, that's going to be equal to k to the exponent of what? Yeah. 8. Good. We're just adding them, right? K, all the way 5 k's. All right, so if we create our own example, the only thing we have to be aware of is that the base has to be the same. So the base being that number 13. So this is going to be equal to, yeah, Adam?
13 to the 7th exponent.
Good. So 13 to the exponent of 7. Excellent. All right, so now if we look at division, down here in this table, 5 to the exponent of 3 divided by 5 to the exponent of 5 divided by 5 to the exponent of 3. Well, another way of writing that division is this line here. Okay? When we write numerator over the denominator, this line also represents divided by. So then we write the expanded form on top, so 5 times 5 times 5 times 5 times 5 divided by 5 times 5 times 5, 5 to the exponent of 3 on the bottom. And then what we notice is we can say 5 divided by 5 is just 1, so they cross out. 5 divided by 5 is another 1, they cross out. And they cross out, and we're left with just 2 5s left. So we know that's 5 squared. And then we notice what's the relationship here between the quotient form and the single power? Tim?
Yes.
What's the relationship here between the quotient form and the single power?
Oh, the first exponent is going to be subtracted by the third one. Second one.
Yeah, so when you're dividing powers, you subtract the exponents. Okay? As long as the base is the same. Okay, I'll say that again. The base has to be the same. All right? So this 7 to the exponent of 4 divided by 7 to the exponent of 1, or even if it was just 7, you don't have to show that 1 because it's always a 1 there, right? This is going to be equal to 7 to the exponent of 3, 4 minus 1. Okay? Here, p to the exponent of 8 divided by p to the exponent of 5 is going to be p to the exponent of 3. Any questions there? All right, so knowing that then, here are the laws, the product, or the rules, the product rule. if we have x raised to an exponent of a times x raised to an exponent of b, we're going to add those two exponents. When you multiply powers, you add the exponents. Okay? When you divide powers, you subtract the exponents. Okay, so we've learned that. So, one question on the test might be, here is the power rule. Okay, and I'll give you this, let's say. I might ask you to prove that rule. Okay, how would you prove it? Yeah.
By giving an example.
Yeah, you would go back to expanded form and an example. You would say 5 to the exponent of 3. Well, that's just equal to 5 times 5 times 5. 5 to the exponent of 2 is equal to 5 times 5. So then if I wanted to do 5 to the exponent of 3 times 5 to the exponent of 2, you would show that that is that. Okay? So the beginning part is important because it allows us to establish these formulas or these rules. Okay? So it's important that you guys remember that and are aware of that, not just memorizing, simple formulas. Any questions there? So the same thing goes for the quotient rule. You need to understand where that rule came from. It came from having one power on top of another and crossing out the same values, dividing by 1. Okay? So now let's go to apply these. We can do these quite quickly. They're quite easy. So 3 to the exponent of 2 times 3 to the exponent of 3. Max.
Sorry, say it again.
A. 1A.
That would be 3 to the power of 5.
Okay, good. It says write each product as a single power, then evaluate the power. So to get from 3 to the exponent of 5 to 243, you probably use your calculator at that point. Okay? You should have an exponent button on your calculator where you can put any exponent. There's this button on your calculator which means squared. Some of you might have this button too, but there should also be a button like this, okay, which will allow you to put in any exponent value. Okay, so you could press 3, this button, and then 5, and that will be 3 to the exponent of 5. Okay, very important to learn how to use your calculator. All right, B here. Michael. 1B.
5 to the power of 4.
Good. So you just add the exponents. You don't see it there, but there's a little 1 right there. Christian?
Is it 5 to the power of 5?
Oh, sorry, my fault. Yeah. See that 1? You have to add that, Michael. Sorry. We both missed it. 2 plus 1 plus 2. 5 to the exponent of 5. Okay? Joseph in the middle there. C?
Negative 2 to the exponent of 7.
Excellent. So even though it's negative, it's still the same base. You're still going to add the exponents. Okay, Salvatore, D?
It's going to be 1/2 to the exponent of 5.
Excellent. So even though we have a fraction as the base, that doesn't phase us. We're still just going to add the exponents when we're multiplying powers. Kyle, the last one?
0.1 to the power of 6.
Excellent. Any questions there? Easy stuff. All right. Down here, example 2. Now we're using the quotient rule. AJ, A, number 2A, right here.
Solution?
Yep.
Okay. The base are the same, so I can add the exponents. So 3 to the power...
Careful, it's division.
Wait, where are we? Oh, okay. So 8 to the power of 7 divided by 8 to the power of 5. So there's 8 sevens and there's 8 fives. Then you take away 5 from 7, and then you'll get 8 to the power of 2.
Okay. So notice how AJ kept saying 8 to the power of 7 to the power. That's not right, okay? The whole thing is the power. Okay? The exponent is the raised factor, the raised number. Okay, Matthew here in the front, B.
4 to the power of 3.
4, 7 minus 1. is 5 minus 3 is 2, right? 7 minus 1 is 6 minus 3. Sorry, 6 minus 3 is 3. Is that what you said?
Yes.
4 to the exponent of 3? Okay. Sorry. Kyle. Sorry, Justin. C.
So you would subtract, so it's 8, or no, negative 2 to the exponent of 4, or wait, oh, negative 0.5 to the exponent of 6 divided by negative 0.5 to the exponent of 3. You would subtract 3 from 6.
Yep.
And then the answer would be negative 0.5 to the exponent of 3.
Good. Excellent. Okay, and it's important, it says write them as a single power, then evaluate. So we have to actually write the final answer of these, right? We have to write these out. Yeah, thanks. And this one?
1.25.
Thanks. And it's going to be negative, right? Because it's an odd exponent, right? Remember that rule yesterday from yesterday, guys?
Yeah.
Okay, good. Finally, last one here, D. Okay, Salvatore.
So you're gonna do the top first.
Yep.
And make them one each. So you're gonna do 3/4 to the exponent of 3 times 3/4 to the exponent of 2, and you're gonna get 3/4 to the exponent of 5. And then you're gonna divide the 2. So you're gonna add the bottom. You're gonna do 3/4 to the exponent of 5 divided by 3/4 to the exponent of 5, and get 3/4 to the exponent of 1. Or just 3/4.
Careful. So you wouldn't get 3/4 to the exponent of 1 because you're getting 5 minus 5. So you have 3/4 to the exponent of 0, which is? No, that's possible. You can have an exponent of 0. Yeah, on the end?
1.
Yeah, 1. Any value to the exponent of 0 is 1. Okay?
Sir, if it's an exponent of 1, do you have to put that exponent?
No, you don't have to write it.
Can you just say like 3 over 4?
Yes. So do you see how, Salvatore, this is the same number as this, right? So they cross out and give you 1. Right? All right. Let's go to example 3. Oh, sorry. Let's look at this investigate. So we're here, down here. Investigate B. So now we're looking to raise a power to an exponent. It says a power of a power. It should say exponent of a power. So it's raised, this power is raised to the exponent of 3. So when we expand that out, we take 2 squared and we multiply it by itself 3 times. And then we're going to deal with what's inside the bracket. So 2 squared is actually 2 times 2. So we expand it further. So we get 2 times 2 times 2 times 2 all the way. We can count them 2 to the exponent of 6. Okay? If we do the same thing with this one, we start to see a pattern that with the exponents, you're actually just doing what? What are we doing with the exponents? Hugo. See up here on the screen, see the pattern? 2 squared raised to the exponent of 3 is 2 to the exponent of 6. 5 cubed raised to the exponent of 4 is 5 to the exponent of 12. So what are we doing? Right, you multiply the exponent. Good. So when you have a power raised to an exponent, the law is you multiply the exponents. Okay? So that's called the power rule. That's right here. Everyone understands what this means, right? The x and the a, b. Everyone understands that, right? It just means any number. Okay? All right, but it's important that the base, well, the base here doesn't have to be the same because there's only one base, right? So we're applying the power rule here. Alvin, the first one.
3 to the power, 3 to the exponent of 8.
Good. And then you would give an answer for that. Yeah?
Just a question. What would you call that, though? Like 3 to the exponent of 2 to the exponent of 4?
You would say 3 to the exponent of 2 raised to the exponent of 4.
Okay.
Okay? If you wanted to read that, right? That's what you're asking?
Yeah.
Okay, Nicholas, the next one.
So,
B, 3b.
yeah, so negative 2 to the exponent of 12.
Good, excellent. Okay, and then you would put that on your calculator and make sure you put a final answer because it says evaluate the power. Okay, that's important. All right, this one over here. Let's go, Mark.
So it would be 2 over 3 to the exponent of 4.
Excellent. Not adding them, but still multiplying, you still get 4. And Joseph in front.
0.2 to the exponent of 6.
Excellent. Easy stuff so far. All right, number 4. Adam, okay, A.
Y to the power of 8.
Right, y to the power of 8, we're just adding the exponents, good. Luca, next one, B, this one.
P to the power of 10. Oh, well,
Careful, it's division.
sorry. P to the power of 4.
Yeah, so that's part of it. Remember, it's like this, 6p to the 7 over 3p to the 3. So you're right, part of it is p to the 4, but you have to deal with the constants, the numbers. So what is this number going to be here in front?
2.
Right, 6 divided by 3 is 2. Okay? So you have to divide the numbers and the variables separately. Henry, C?
8 to the power of 8, e to the power of 7.
Yep, a to the power of 8 and b to the power of 7. Excellent. And last one here, Tyler.
Alright, so negative 2 multiplied by u times a
Yeah?
square, u to the exponent 2. So what you want to do first is you see u, so you subtract it on the other side. So it only leaves one variable u. And then v, the exponent of 3 subtract v to the exponent of 2 makes it v. And then negative 2 plus
Okay, why are you...
negative 2 multiplying.
Hold up. Okay, hold on a second. Okay, let's deal with the numerator first. Okay, so tell me what's going to be on the top, and then we'll deal with the bottom. Okay?
So it's going to be negative 16
Good.
multiplied by u multiplied by v.
Okay, so that's these two terms combined?
Yeah.
Okay, careful, because you're adding the exponents of u, or here u.
Sorry, yeah, you're adding on the exponents of u, so it would be u to the exponent of 3 and v to the exponent of 5.
Excellent, okay. And now we'll leave. Now the denominator, what are you going to do with that?
And then at the bottom, we have v to the exponent of 2 multiplied by 2, so it equals 4 times u times v to the exponent of 4.
Okay, so careful now. This exponent here on the bottom, it applies not just to the v, but it also applies to the u, and it also applies to the 4. Okay? So when you have something like this, look up on the screen, okay? When you have something like this, that's actually equal to this. Okay? Because all those things are in brackets, that square belongs to each one of them. Okay? If it wasn't in brackets, if it was only on the last v, then it would only belong to the v. But because everything is in brackets, that exponent goes to every term. Just like we talked about yesterday, if we had a fraction squared, that square applies to both the numerator and the denominator. Okay? So now if we think about this, tell me what the bottom is going to be, the denominator here.
It will be 16
Yeah.
multiplied u to the exponent 2 multiplied v to the exponent 4.
Excellent. Okay, and now finish it off.
So then negative 16 divides 6 equals negative 1.
Yep.
divided by u to the exponent of 3 divided by u to the exponent of 2
Is equal to what?
u to the exponent 3 divided by u to the exponent 2 equals u to the exponent of 1.
Okay.
And v to the exponent of 5 divided by v to the exponent of 4 equals v.
Okay, so I didn't write this one in here, and I didn't write that one in there, and I didn't write that one in there. Okay, you don't have to write any of those ones. All right, everyone understand that? Okay, so our answer is negative uv, which is down here as well. Okay, so finally, the key concept. The exponent laws are a simple way, are a way to simplify expressions involving powers with the same bases. When multiplying powers with the same base, add the exponents. When dividing, subtract the exponents. When finding the power of a power, or the exponent of a power, multiply the exponents. Okay, 3 very simple rules. That's it.